Okay, folks, video is on. All right, so if we were going to name that first one, folks, what would we do first? Count the what?
Number the carbon.
Yeah, you'd number the carbon. So first of all, we'd go, okay, we've got 4 carbons there, right? So that's gonna have some kind of butte in the name, right? Is that okay with everybody? Okay. And then my friend in the back said, well, let me go ahead and number that. Let me erase that and write that a little bit better. So something like butane, butene, butine, something with a BUT in it because it's got 4 carbons. Now it has a double bond in there, so what's the ending probably gonna be on this one? And we're doing this one right here. Yes, E-N-E. And the E means we've got a double bond. So numbering it, are we gonna number left to right or right to left?
Doesn't matter.
Doesn't matter, because either way that double bond is going to start on carbon number what? Yes. Either way, the double bond is going to start on carbon number 2. And when we name things that have a double bond, we want to locate the double bond and give it a number, that location, give it a number, but we don't have to say both of the numbers, we just have to say where it starts. So that means that this guy's going to be named what? 2-butene. Is everybody okay with this? This is 2-butene. All right, the ones on the bottom left, the longest continuous carbon chain is how many carbons?
4.
It's 4. So you can see without picking up your pencil that you've got 4 carbons there. Do you see that, folks? Okay. So does it matter which way we number this one, left to right or right to left? No. So 1, 2, 3, 4. We could have gone the other way also, right? This one will be called what? This one is also 2-butene. What about the one on the bottom right? What is the longest continuous carbon chain? How many carbons there? 4. So we have 1, 2, 3, 4, like that. Do you guys see that? Okay. So it's not drawn like the one on the top where it's all straight. It's drawn so you can see how the structure is in 3D there. Now the number for the one on the bottom, sorry, not the number, the name for the one on the bottom right will be what? 2-butene. Now if we look at the ones on the bottom there, what we can see is that there's definitely something different about those. But we see that they have the same name, right? And if you have the same name, you have to be the same molecule. So there must be something different in the name that we can do to indicate that these 2 things are different. And to prove to you that they're different, I want to show you the models for them, and I'll also show you the characteristics for each of these. So let me pause for a second to grab the models. And also, I want to put this on airplane mode so we're not getting notifications. It is on airplane mode. Why am I getting notifications? It's on Do Not Disturb. Oh, there we go. Well, airplane mode should take care of that. Anyways, okay, so here we go. All right, so 2-butene. Why the differences here? So this one up here, it's just drawn in the condensed format. So we can't see spatially where everything is. But with these, with the full structural formula, or almost full structural formula, if we went super full structural, we'd see all the hydrogens drawn out. We get a clue as to the shape of these things. So this one looks like this right here. And you can see that these CH3s are on the same side of the double bond, whereas the hydrogens right here are also on the same side of the double bond, but not the same side as the methyl groups. Does that make sense, folks? And with this one over here, this 2 butane, what we can see is that it looks like that. So we have one of the methyl groups on one side of the double bond, and we have the other methyl group on the other side of the double bond. And these two molecules are indeed different. But the name is the same, so the name is saying it's the same molecule, so we have to make a difference in the name somehow, and that brings us to cis and trans. So, if you have the non-hydrogen groups, the big groups, on the same side of the double bond, right there, that's gonna be your cis 2 butane, and you put CIS and then -2 right before butene. So that's cis 2 butane. And if you have your non-hydrogen groups across the double bond, like that, that one is trans 2 butene. Now, why this difference? Well, they are in fact different molecules, and they do in fact have different characteristics. So if I slide down to this slide right here, number 19, that says properties of 2-butene, you can see that they in fact have different melting points, different boiling points, and different densities. So if you're doing some kind of reaction, and you need one of them, you definitely don't want to grab the bottle of the other one. And so we need to make a distinction there. Now, why are these things different? Well, that has to do with the restriction and rotation around the double bond. So we talked about this a little bit in lecture, but I want to show you this again. And where is my ethane and my ethylene, also called ethene? So if we take a look at ethane here, you can see that you've got free rotation around the double bond, around the single bond, bad teacher bad. Whereas with the double bond, things are locked into place. And you don't really see the difference when we're talking about an ethylene that has all hydrogens around it. But if we're looking at our cis 2 butene, you can see that you can't just rotate this in order to get this one right here. And you can't just rotate this one to get this one right here. These are locked into place. They are different. And you can see that right here, that there's no rotation around that. Now, if you wanted to look at the bonding pattern here, here's the little picture. So where we have sigma bonds and pi bonds, but don't worry about that too much unless you're gonna go on to general chemistry and organic chemistry, then you'll see that a little bit more. But if you remember back to s orbitals and p orbitals, that's what you're looking at right here. Otherwise, don't worry about that too much. This won't occur on the test. I was just showing you guys with a picture of what that's looking like, okay? Questions on this before we keep going? Yes, ma'am, in the back.
On the worksheets and exam, do you want us to like name one cis or trans?
I sure do.
Okay.
Can you go back up?
Can I go back up
Just go.
to this one right here?
Yeah.
Absolutely. Well, my friend over there is drawing something. I want to warn you folks about something. So most of the time, when students see our 2-butene drawn in this form, we have no problem naming that 2-butene. We don't know if it's cis or trans because it's not drawn to where you could know that it's cis or trans, so you just put 2-butene. But looking at the structures on the bottom, what students often see with their eyeballs is this right here, and we want to call that 1,2-dimethyl ethene. But the problem is the longest continuous carbon chain is not 2 carbons long. Do you guys see how it would be really easy to make that mistake there? Because the longest continuous carbon chain is 4 carbons. It's just drawn to where it looks like it's an ethene with 2 methyl branches. So no, 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 no. Are you guys all right with that? Okay, so watch out for that mistake. Okay, so we talked about restricted rotation. Now let's go ahead and take a look at this slide right here. And this is talking about how to recognize when you need a cis and a trans differentiation. So it says if either carbon of the double bond has identical substituents, so remember a substituent's another name for branch. So if you're looking at one carbon and it has the same thing bonded to it, like one butene here has 2 hydrogens, so that's the same substituent, okay? Cis trans isomers are not possible. What you have to have is, you have to have 2 different things on one carbon and 2 different things on the other carbon. Now this picture right here is a little bit confusing because it makes it look like you have to have 4 different things bonded around here. But what it's actually saying is in order to have a cis-trans pair, look at this carbon right here and ask yourself, are those 2 things different from each other? Okay? And then you have to go to the other side and ask yourself, are those 2 things different from each other? And if you have yes and yes on both carbons, then you can have cis-trans. If we go back up here to 1-butene and we look at this carbon right here, okay? Is this hydrogen and whatever else this is here, don't worry about what it is, are those 2 things different? Yes, so that side qualifies. And then you go over here and ask yourself, are those 2 things different? No, those are the same thing. So this one's not going to have a cis trans isomers. You're just going to have a 1-butene. Is that okay with us right now? Don't worry, we'll practice this, okay? So, cis trans isomers, these are special isomers called stereoisomers. So remember we've done regular isomers, which are also called constitutional or structural isomers. Those ones have the same molecular formula, they just connect the atoms in a different way, so different connectivity. So both ethanol and dimethyl ether have molecular formulas of C2, what? Keep going for me, folks. H what?
6.
6, and
Oh, 1.
yeah, oh. You can put the 1 there if you want, but when it's a 1, most of the time you don't put the 1 there. Yeah, okay. So those have the same molecular formula, but the atoms are connected in a different way. Whereas stereoisomers are going to have not only the same molecular formula, but the atoms are going to be connected in the same order. So the molecular formula for cis-2-butene and trans-2-butene, we've got C what? How many carbons for butenes?
4.
4. H what? 8. And anything else?
No.
Nope, just C4H8. Okay, so both of these are C4H8, so we know there's some kind of isomer, right? If we're looking at structural or constitutional isomer, you have different connection of atoms. So we had CCO, and here we had COC. So we can see how they're connected differently, right, folks? All right, here what we have is we have a carbon that's bonded to 3 hydrogens, And that carbon is bonded to a carbon that's bonded to a hydrogen and also double bonded to another carbon that is bonded to a carbon that's bonded to 3 hydrogens and it's bonded to a hydrogen. So do you see how the connection is the same? But the difference is that in 3D, they're spatially different. So that's a little bit of difference there. So those are called stereoisomers. And in chapter 15, I believe it's chapter 15, we'll do a whole lot with stereoisomers. Aren't you guys excited?
Yeah.
Woohoo! Okay. So we don't just have cis trans isomers, we also have other kinds of stereoisomers. Now, what on earth did I just say? Well, here's a picture of it. So if we're looking at 1-butene, cis-2-butene, and trans-2-butene, all of those have a molecular formula of what? C what?
4,
C4H8. All 3 of those. C4H8. So that's why it says that all of them right there would qualify as isomers because they have the same molecular formula, right? Okay, but there's a little bit of a difference when we talk about which ones are constitutional isomers and which ones are stereoisomers. So the cis trans isomers are stereoisomers. Okay, so 1-butene is going to be a constitutional or structural isomer with both cis-2-butene and trans-2-butene. So you can see constitutional isomers here, constitutional isomers here. Now, there is a different connection of the atoms between 1-butene and the cis and trans ones over there, because you can already see that on the end you have a carbon, and this one's bonded to 2 hydrogens, but this one is bonded to a hydrogen and a CH3. So there's a different connection there. And then these 2 are stereoisomers, because not only do they have the same molecular formula, but they have the same connection of the atoms, which we did on the last slide. They're just different spatially, so they're different in 3D. Are we okay with this, folks? Kinda, sorta, maybe? We might need to do some examples. No answer. Woohoo! Okay. All right. So again, the properties of cis and trans 2-butene, and the butene there should have a lowercase b, but anyways, not such a big deal. We can see that these are actually different molecules with different properties. All right. We've got some problems here, and I have no idea why they're all A. 1A, 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 and 1A. That must have been when I went from PowerPoint to Google Docs and it went and munched it all up. But anyways, we'll roll. Okay, so the first 1A, that is CH3, CH double bond CH2. And the question is, which of the following compounds can exist as cis-trans isomers, and draw each cis-trans pair if it can exist as cis-trans isomers. So the first thing we're gonna do is we're gonna look at the carbon on each side of the double bond and ask ourselves, is this carbon bonded to 2 different things? And is this carbon bonded to 2 different things? We might have to draw it out to see it better. If you do, that's okay, you're learning. So I'm just gonna draw this out. So we can see it a little bit better. And it does not matter if I put this CH3 up here or down here. It doesn't matter which way they go. And it doesn't matter if I put CH3 or H3C. Okay, folks? So go ahead and put your hand on one side so you're just looking at one of the carbons of the double bond. Is this carbon bonded to 2 different things? It sure is. So it qualifies at this point, but we have to look at the other carbon. That carbon, is it bonded to 2 different things? No. So are there cis trans isomers here? No, there's no cis trans isomers here. This is just propene. Okay, you can call it one propene if you want, but it doesn't matter where you put the double bond because either side, you're gonna number it so that it's one propene. Does that make sense, folks? Okay, so the first one, we've got a no on that one. Okay, the second one, let me draw it out so we can see more clearly what the formula is. Okay, so put your hand over this side and just look at this carbon right here. This carbon right here is bonded to what? It's bonded to a hydrogen and whatever else this is over here, right, folks? Let me draw that out so it's easier for us to see. Okay, folks, can we see how this is translated into this? How this carbon right here is this carbon? Are we okay with this? Yes, no, maybe so. Okay, so look at them each individually. This carbon is bonded to a hydrogen and an ethyl group, CH2, CH3. Are those two things different? Yes. So we've got a yes on this side. Looking at this side, this is bonded to a hydrogen and a methyl group. Are those two things different? They sure are. So you have a yes and a yes there. So do we have a cis and trans there? Yes. Yes. Okay. The one that I already drew, this one right here, is this going to be cis or trans? This is cis. Your big groups are on the same side of the double bond. Right there. Your hydrogens, your little groups, are also on the same side of the double bond. Your big groups would have to be trans or have to be on the other sides of the double bond. So what we're going to do to get the trans version is you're going to flip one side. But before I do that, let's name this one. So we have cis, and we'd go, okay, I need to number this thing, and I want to keep the double bond having the lowest number possible. So am I numbering forwards or backwards on this one? So you want 1, 2, 3, 4, 5. Do you guys see why I numbered backwards on that one? Okay. That means that your double bond starts on carbon number what? 2. If you went left to right, your double bond would start on what? Carbon number 3. Now, again, folks, don't name this as an ethyl, methyl, ethene. The longest continuous carbon chain is that right there, okay? So it's really easy to make that mistake. All right, so we've got a cis, 2. My friend over there said pentene. Do we see that our longest continuous carbon chain is 5 carbons long? So that's some kind of pent. And do we understand why we have the ene on the ending? Okay. And we have to see where the double bond is. Well, it starts at carbon 2 and goes to carbon 3. Okay. So we've got 2 pentene, and it's the cis version. What is the trans version going to look like, folks?
Oh, you flip one side?
You just flip one side. Either side you can pick, okay? And when you number it and name it, it'll end up being trans. So let's go ahead and flip the right side. So that would give us a structure that looks like this. took these two and we flipped them around. Okay, folks, so now we can see that our big groups go across the double bond like that. You see that? Are we okay with that, folks? So that means that this one is going to be trans what? Trans 2-pentene. Now, when you get a little more into organic chemistry, like if you took Chem 12A and 12B, instead of cis and trans, you're going to use something called E and Z, but we are not going to worry about E and Z in this class. So if you're Googling something and you see E or Z, don't worry about it. It's like a fancy way to do cis and trans. There's a little more to it, but this is 2B, not 12B, okay? All right, so are we okay with the answer for the second 1A being a yes?
Yes.
Woohoo! Okay, so this one is a big fat yes. Now, did everybody write all this down so I can erase it so we can do the next two? Yep, okay, good, good. Okay, the third 1A, this one right here. What do we think about that one? Are we having a yes or a no on that one?
Yeah. No.
Okay, so I got a no shaking head and I got a yes and a no back there. What if I draw it out? Might make it a little bit easier. So I always start with the carbons of the double bond and then stick the stuff on there. So on the left-hand side, it says that we've got 2 CH3s. So right there, you should see this one's gonna be a no, right?
Yeah.
Okay. And on the other side of the double bond, we've got an H and a CH3. Is everybody okay with the fact that this is that? You all right with that? Okay. Now, if I were to take this and flip it over, we would still have the same molecule. Let me see if I made that. I don't think I made that molecule. All right. Anyways, if we look at this one, we're looking at that side, and you can see this is bonded to a CH3, bonded to a CH3. Are those two things the same thing? Yep, so doesn't qualify. If you did that side first, you'd be like a yes on that side, but then you go to that side and you see it's a no. All right? So the third 1A is a big fat no. Alrighty, what about the fourth one?
Yes.
Okay, so let me draw this out. So again, go ahead and put the 2 carbons of the double bond, and then on one side, fill in, and we've got a chlorine, and we've got a hydrogen, and on the other side, we've got a chlorine and a hydrogen. The way that I drew it, we can see that this carbon is bonded to 2 different things, so there's a yes there. And then looking at that carbon, it's bonded to 2 different things, so there's a yes there. And then we can see that our non-hydrogens are on the same side of the double bond. You guys see that? Okay, so let me go ahead and put a little circle around this. So that's telling you that we've got a yes on this one for their cis trans isomers. And the way that I've drawn it here, we're gonna start the name with what? Cis. So you've got cis, and then we gotta go, okay, well, what is the actual name of this thing? Well, how many carbons in your longest continuous carbon chain? You've got 2, and it's got a double bond, so instead of ethane, it's what? Ethene, so the parent is ethene, so that's gonna be at the end. But before that, we have to say what the branches are. Now, looking at these folks up here, they're not CH3s, where when we had butene, remember it was a CH3 here and a CH3 there, and I was like, whoa, don't name it as an ethene, name it as a butene. Well, here our longest continuous carbon chain is just 2 carbons long. So the chlorines there, those are branches. So we're gonna have cis 1, 2, what? Dichloro. What? Ethene. Yep. 1, 2 dichloroethene. So we go 1 and 2, or you could have number the other way, right, folks? Yes, no, maybe so? Any questions for me? Okay, now to draw the trans version, which I could have done first, but I just chose to draw the cis version, what would you do to the cis version?
Flip with the sides.
Flip one side. Don't flip both of them, because if you flip both of them, you're just turning this molecule upside down. And if you just turn this one upside down, it's still the same thing. You didn't break any bonds or make any bonds there, okay? So we just flip one side, and what we get if we flip one side, and either side will do, folks. I just chose the right side because I have the pen. Okay? So for this one right here, can we see that the non-hydrogen groups are on the opposite side of the double bond? Yes, no, maybe so? Okay, so you're crossing the double bond right there. So that means that this name starts with what? Trans. So we've got trans what?
1, 2, 2,
Yep, trans 1, 2 dichloroethene. So this one was a yes.
Where did you get ethene from?
This right here is the longest continuous carbon chain, and it's 2 carbons long. So whenever you have a carbon chain that's 2 carbons and that's it, it's gonna start with F. So if it's just single bonds, like this one right here, that's gonna be ethane. And if you've got a double bond, that's what? Ethene. And if you've got a triple bond, that's what? Ethyne. Because alkanes end with ane, and alkenes end with ene, and alkynes end with what? Ine. No answer. Okay, ine. Woohoo! All right, folks. Questions for me before we go on to the next slide? Good? Okay. So number 2 there says there are 2 isomers for 3-methyl 2-pentene. We want to draw both of them. Okay, folks. We're drawing this one right here. Oops. I guess that wasn't that great. I'll put a little arrow. There we go. Okay, so let's just draw the condensed form of it so we know what we're looking at, and then we'll draw it out more in the structural form. Okay, pentene. That's saying that we have how many carbons, folks? 5. So maybe you just want to go ahead and put 5 carbons in a row. That's okay, you're learning. Okay, so 2-pentene, that means you have a double bond where?
The second one.
Yeah, between 2 and 3, right there. Okay, we've taken care of 2-pentene, and now we need to take care of 3-methyl. So what do I want to put on the 3rd carbon? A methyl group, which is what? CH3. I can draw it up or I can draw it down, either way. Okay, so now what I'm missing are my hydrogens. So if you needed to draw all your hydrogens in, it would look like this. And that would mean that to clean it up a little bit, folks, it would look like this. Are we okay with that? So that's 3-methyl 2-pentene. Okay. So same thing there. Now, if we want to draw it in cis carbon-carbon double bond first, and then we're gonna go ahead and put our different branches on there, okay? So what we're looking at is right here. Now, over on the left-hand side, you guys can see you've got a CH3, and it doesn't matter. You can draw it on the top or on the bottom, because your first one is either gonna be cis or trans, and then the second one, you're gonna flip one side and it'll be the other one, okay? So you can go ahead and put it top or bottom. So we've got CH3 there, and then we've got the hydrogen there. Are we okay with this, folks? Okay. And then on the other side, we can see we've got a CH3 and we've got a CH2CH3. And again, it doesn't matter where we put it. We could have flipped those two things around. Okay, this one looks a little bit different, because on one side we don't have a hydrogen. And again, this might be a spot where we want to use the E and Z thing, but this is 2B, not 12B, so we're going to stay simple on this one, okay? Now, looking at each side, this side's pretty simple, right? Is that carbon bonded to two different things? Okay, a hydrogen and a methyl group, those two things are different. Then you look at this side and you ask yourself, is this carbon of the double bond bonded to two different things? It is. And then some people's brains might go, but it's bonded to a carbon and a carbon. Aren't those the same thing? Well, like, if you think about it that way, yes, but how we're thinking about it is the whole blob here. This is a methyl group, whereas this is an ethyl group. So is this blob different from that blob? Yes. So this carbon is bonded to two different things, and this carbon is bonded to two different things. So we're qualifying here. All right. Now, on the right-hand side, you don't have a hydrogen to be your smallest guy, okay? So this is a little bit different in that sense, too. So on the left-hand side, what we have is that the methyl group is the big guy. And on the right-hand side, we have that the ethyl group is the big guy. So this one is going to qualify as the trans. Or it would be E or Entgegen if we were in OChem, okay? So what we have is trans 2, and the 2 is saying where our double bond starts. And what is the longest continuous carbon chain here? How many carbons?
5.
It's 5, and we saw that up here when we looked at the name that said Pentene. So we have trans 2 what? Pentene, but I forgot something. What did I forget? There's also this methyl branch right there, right? So I have to back up a little bit and I have to add the methyl in. Ah! So I want to put trans 3-methyl, and I'm running out of room. 2-pentene. Ah, right? That one was a little more difficult. Okay. Don't worry, they don't generally get this involved. I just kind of wanted to show you guys something that you would see. All right, now how do I get to the cis? I would flip one side, and since I have the pen, I'm choosing the left side. And I'm leaving the right side alone, because if I flipped both things, I would just be back to trans. And then that would give me cis 3-methyl 2-pentene. because your big groups are on the same side. You would look at this right here and you would say which one is bigger, the methyl group or the hydrogen. And in this case, it's the methyl group. And then you would look at this side and you say which is bigger, the methyl group or the ethyl group. And on this one, it's the ethyl group. So my bigger groups are on the same side here of the double bond. If we were doing E and Z, it would be Z because your big groups are on Z same side or Z. Okay? So, are we okay with this, folks? So that's the cis and trans thing. You will need cis and trans for 2 of your molecules on study assignment 9, and I believe on Canvas I identified those for you. I think it might be 2B and 4B. Did anyone read that? Okay, so make sure you give me a cis or a trans on those ones. Any questions for me before I put my iPad away? Yes, go ahead.
Would it be a worksheet or?
Yes. Let me get whatever questions are on this presentation first, and then we'll do that. Yes, sir.
You already answered the question.
Okay. When I put this away, it's gone. So, questions? Yes.
Okay, so does this only apply to double bonds, like not triple bonds? Would it apply?
Triple bonds, each carbon of the triple bond is only going to have one thing
Oh yeah. I
bonded to
forgot.
it.
Okay.
Yeah. So, yeah, just our alkenes.
Thank you.
You're welcome. Okay, last call for anything on the presentation, folks. No, we're good? Okay, I'm gonna shut the video off.